Okay, boys and girls, let us start our lesson today. Okay, we continue last week lesson. Last week we stopped at lesson number 32, and then I asked you complete page number 7 and 8. And then just now in the WhatsApp, I already print out the answer, how to complete it. Okay. So, okay, this question, what you count actually at here, I think you counting, let me have a look. You will get the answer like degree. If extra moving, you get 17 degree. Okay, so in total, if in total, what is the angle alpha? Let me have a look. What is the angle alpha? 35 plus 17. Oh, okay. That means that this one, compared to the first one just now at here is 35. So you are extra at here, extra turn 17 degree. So your alpha actually is added up 35 plus 17. Okay, this one you can refer to my working set. Okay, already print out. I already print screen and show in the WhatsApp. Okay, here, boys and girls, we comes to here. A beam with a vertical polarized. Okay, vertical polarized. Okay, it's incident normally on a polarizing filter. Okay, initially at angle is 0. Angle is 0 degree. It allow the wave to pass through. Okay, it allow it to pass through because they are in the same direction. What? Okay, it allow it to just pass through. So that means that at 0 degree, this is the maximum value. It will be pass through with maximum value. So this one maximum. Okay, so here is maximum. This one maximum, this point is maximum. Okay, when 90 degrees, so you imagine, if 90 degree, that means that like this. Okay, it turn 90 degree. So if like this, actually your vertically will be exactly totally, it will be blocked. So at this position, it will become 0. Okay, then after that you continue turn, become 180 degree. So you come back to the vertical position. So at this moment, another 90 degree, which means that compare with the initial is 180 lah. So this one is going to maximum again. So minimum again, maximum again. So how was your graph? Actually, your graph will be looks like this. Something like this. Okay, according to our notes, we also got this graph. Let me have a look. This. Can you see that? Exactly like this. So can you see that initially it allowed it to pass through, okay? But if you turn another filter, this is vertically. So it's same like just now our vertical incidence wave, initially vertical polarized light. Okay, it passing through. If this one initially is vertical, so it just pass through. So maximum. When you turn 90 degree, it block. Or it's blocking. So at the end, the answer actually is this graph. Okay, answer is this. So here, come back to this question. Okay, so at here, the intensity for the incidence. So this one I label I or label IO also can, doesn't matter. Okay, when the transmission axis is at the angle delta to the vertical, the light intensity, this one is after that it become like this. This is new lah. Okay, with a filter with a certain angle, so we get a new intensity. Okay, so it's reducing. Okay, so at here I new equals to the incidence, then cos square delta. They want to find the angle. The new one is 4.2, the incident is 7.6, then cos square delta. So data at here, if you press your calculator correctly, you should able to get the answer 42 degree. This is just apply formula only. So I'm not letting you try lah, no need to try lah. It's just put in the formula, Malus law, then after that you find the angle. Okay, so is that clear for this question? Okay, Wesley, Fatima, Vashini. Okay, For those, if you want to try by yourself, you just write down final answer. Then after that, you trying to complete by yourself for the working step part. Okay, we goes to the next question. Question C, 6C. Okay, here. Vertical polarized monochromatic light is incidence to the filter. Okay. The filter is positioned with its transmission axis at angle 20 degree to the vertical. Okay, this is the angle. Then the incidence light has the intensity IO. Transmitted, that means after the filter is IT. By considering the ratio of IT over IO. Okay, IT over IO. So at here, we understand that I is equals to IO cos square theta. Okay, so your IT actually is what? Your IT actually is your IO cos square theta, right? This one I don't write first. Okay, here. But the problem is they ask you to calculate the ratio of amplitude, intensity and amplitude. Okay. In this chapter, I think it's second lesson. Okay, we're talking about the intensity and amplitude. So intensity and amplitude formula is I is actually directly proportional to amplitude square. Okay, this is the formula that we learn in this chapter. I think it's not mistaken, it's second lesson. So this one is equals to Ka squared. I add a constant value for it because I make it becomes equal. Okay, so I need to make this, okay, make this related with this, okay, related to it. So at here, what can I do is IT is actually, let me have a look. Okay, here Ka squared. Okay, transmitted, or I write T. This is T equals to IO. IO is KAO squared, right? Then cos square theta. Okay, so basically here I make it KA squared. Then this one IO is KAO squared. Okay, I relate with this formula because at the end I want actually this AT square over AO square. What is this? And then at the end, I want to know AT equal AT over AO. What is this? So this is the part that you have to do. So we have to relate not only one formula, we have to think. Intensity, we can using the Malus law, and also what formula we can relate with amplitude. So I is directly proportional to A square. So I make it into equation, become equal Ka squared. So this one I substitute in here and I substitute inside here. So can you try and then tell me your answer? You do your calculation and tell me. Look at the form what we say physical quantity that they have and what they want to relate. And then you think what formula we can use. Wow, Wesley very fast. Yes, Wesley correct. Okay, Wesley already told us the answer is 0.4 ratio. So boys and girls, K and K we can cancel. Okay, cos square theta, cos square of 20. Don't forget square root. Don't forget about the square root. So you square root it, at the end you get 0.94. That's all. At here, the difficult part is you need to think. Okay, polarize intensity and the amplitude, how we link it. How we link intensity and amplitude. So not only with this lesson, but we need to think back the few lesson previously lesson that we learned. Okay, now here, this one is like this. Okay, the filter now is rotate. It continue rotate. About the direction of the light beam from its starting position. So this is starting position. This is starting position. Okay, then the directions of rotation is such that the angle of transmission axis to the vertical initially increase. Oh, okay, they are rotating. Okay, rotating and then increase the angle of the transmission axis to the vertical initially increasing. Okay, calculate the minimum angle through which the filter must be rotated. How much the angle that we need to rotate so that the intensity of the transmission return back to the value that it had when the filter was at initial position. Okay, what does it mean? They say this one is initial, this is initial. Okay, let's say initial, the intensity here didn't mention, okay. Let's say here, this one, of course, is not the maximum one, correct or not? Okay, this is vertical. Then with certain angle, actually, is not a maximum already. We will reduce a bit. Okay, but this one reducing, I want to know how much I rotate the angle. I need to rotate how many angle so that at the end, I get exactly same as here. For example, if let's say we're using just now the case at here, is initially the amplitude, okay, intensity is 7.6. Initially is 7.6. After with certain angle, it becomes 4.2. Now this question is, let's say here is 4.2, then it's 7.6, let's say. So I need to rotate, what is the angle I need to rotate so that at the end I get back 4.2 intensity. This is the meaning. Okay, how we solve it? Okay, here, let's say this one is maximum, right? I rotate 20 degree. So of course, somewhere here, 20 degree, somewhere here. It's not the maximum. Then how many angle I should continue rotate? So at the end, I can get back another same value of the intensity. So you need to find what is this angle. From here to here, how much I should rotate. One more time. This one initially is vertically. But of course, in our case, it's already start to rotate 20. So for example, 20 is somewhere here. Then the question say, somewhere here. Then the question say, how much it should be continue rotate so that at the end they get back the intensity same like here. Same like starting position, which is the 20 degree. So which means that I need to know about this. I need to know about this, right? Okay, so from here to here, okay, from here to here, just now is 20 degree. So until here, actually how much I rotate? I rotate 70, correct or not? I rotate 70. In order to get back the same angle, here to here also another 70. Do you agree? Okay, initially here is 20 degree. Then until the minimum is actually I rotate extra 70 so that I comes to 90. Okay, then after that you want to get back the same intensity, you need to rotate another 70 degree. So in total, what is the angle needed for you to rotate it? Answer is 140 degree. This one have to think a bit. This one have to think. Okay, maybe I can, let me have a look. I capture this. Copy. Okay. Here. Paste. Cannot paste? If cannot paste, then have to draw by myself. Okay, it's okay. Okay, it's okay. Here, dear. Here. Go to here. Go up. Then go down. Go up. Okay. This is 0. Here is 90 degree. This is intensity. Okay, this is the angle. Initially, our case is at 20 degree. So which means that initially we are here, somewhere here. Okay, this is 20 degree. Okay, I know that when I rotate another 70 degree, now I become vertically. Am I right? I rotate another 70 degree, I become horizontal. Okay, the filter become horizontal. So that means that from here to here, I rotate 70, then I get minimum intensity. Then after that, How can I get back another same intensity at here? Okay, basically you should get another 70 degree. So actually, what is the minimum angle that we need to rotate? If we are starting from 20 degree, now how much we need to extra rotate the angle so that we get back the intensity? Answer at here is 140 degree. Okay, this chapter is new chapter for you, so it might be need time for you to digest. But at here, is it okay for you? For my drawing and my explanation, can you understand why we get 140? Yes, Fawa, okay. How about others? Wesley, okay. Honey? Honey, last week I didn't see you. Any others? Okay. Vashini, okay or not? Manjo? Fatima, okay. If okay, then we go to the next page, Next page. Okay. We goes to next page. Okay, this one is letting you, I already give you the answer is because I want to tell you that actually they were asking such question. Okay, so you need to know that you have to know what is the meaning of polarization, and then why is light wave can be polarized but sound wave cannot. Last week I got mentioned, okay, if let's say this one like this, so the wave pass through like this. Okay, if you are sound wave, you are keep on like this, forward, backward. No matter what kinds of filter you use, they just pass through only. So they cannot polarize. Only transverse wave can be polarized. Not horizontal, longitudinal wave cannot. Okay, now here we try two polarized filter A and B are positioned so that their planes are parallel to each other's, okay, and perpendicular to the center axis line XY. Transmission axis of filter A is vertical, and then this one is horizontal. That means that they become 90 degree, okay? Then after that, unpolarized right of a single frequency is directed along the line XY from the source. Then the line from the filter A is vertically, yes, okay. Then after that has intensity IO, okay, here IO, they got right IO. Then after that, filter B is rotate from its starting position about XY as shown. Oh, this is the starting position. Okay, this is their starting position already. They assume this is their starting position. Okay, after rotation, this let me have a look the 1/4 IO. Okay, 1/4 IO. Then here, calculate the angle of rotation of filter B from its starting position. What is the angle of filter from its starting rotation? Oh, okay, how much it should rotate so that at the end, it will get 1/4 IO. Because if like this, 90 degree starting at here, actually it won't have intensity, right? So it start to rotate until it got intensity. So they're asking you, what is the angle of rotation? I repeat one more time, this one they come here. If they pass through the filter B like this, starting position, actually there is no intensity. So they start to rotate until it get intensity 1/4. So they're asking you how much it should be rotate. Wesley, no, but you are almost there. Okay, here we try I is equals to IO cos square theta. Then the new one is 1/4 IO equals to IO cos square theta. Okay, your data at here, you will get, just now Wesley give me the answer is 60 degree. If you do calculation, you will get 60. But 60 is not our answer. Okay, 60 is not our answer. Let me have a look. Okay, here 60 is not our answer. What they want, angle of rotation from its starting position. Let me think. If 60, meaning that is here. Somewhere here 60. Somewhere here 60. But no, we are rotate clockwise. We are rotate clockwise. Okay? So at here, what they want is actually 60. Wait, let me think. Okay, if you continue do calculation, actually it can be 120, 240, or 300. Okay, if 120, 120, it will be somewhere here from the, what you count, delta that you count actually is from the vertical, compared to your A, filter A. You know what I mean? This one is actually angle from the vertical compare with your filter A is vertical. So if you are say 60, actually is on this area. On this area. So we are starting from 90 degree. So your answer won't be 60. Your answer won't be 60. Okay, I repeat one more time. The angle that you calculate actually is the angle that we measure from the filter, vertical filter until the next one. Okay, so it's like this. Let me have a look. Find example to show you. Okay, angle. See, the angle that you count actually is the filter compared with your just now initially the first one. From here, you rotate another how many angle? So the angle that you get is 17 degree. Actually, is from this going. So just now at this case, initial is 0 here. Initial is 0. So if you get delta is 60, actually is compared from the 0 until 60 here. But this is not our answer because our starting position already start from 90 degree. Already start from 90 degree. So 60 degree, this answer is not our answer. This is not our answer. Okay? Then 120, if 120, that means from here to here is 120. Right? Okay, our initial is 90 degree. So the angle that we need, angle of rotation should be 120 minus 90 degree. So it should be 30 degree. You need extra rotate 30 degree. Okay, here the difficulty is, I repeat, this angle that you count actually is compared with your first filter. What is the angle that you need to rotate? So we get 60, that means that we rotate like this, 60 degree. But this is not our answer because on our filter B, we are starting from 90 degree here. So we only can refer to the second answer, 120. If 120 compared to our initial position, we extra rotate 30 degree. We extra rotate 30 degree. That is the answer that we should get. Okay, so at here, your answer can be 30 degree. If you're able to get 30 degree, you already score the mark, full mark already. Okay, if you are getting somewhere here, is actually you get 2 marks. Okay, already get 2 marks, like this, 2 marks. Okay, here, teacher, you say 30 degree. Can I using the 240 and 300 degree to find the rotation? Yes, not only this answer, you can also suggest others answer. For example, 240 degree minus 90, so you get 210 degree. Or 300 degree minus 90 degree, you can get 330 degree. Okay, so Wesley, your second answer is correct. Okay. So boys and girls, a bit complicated. Okay, but at least we know that we need to be very clear. The angle that we measure is actually these two filter. It's based on the first filter here, the angle that I rotate. So 60 degree is not my answer. It's because we are starting from 90 degree. So we refer to your angle with 120. We found out that it need extra 30 degree to rotate it. Okay, digest. 10-second digest and you can ask me question. I know it's not easy. 210. Okay, if let's say here, next angle that to get 1 over 4 IO is 240 degree. If you press your calculator, actually you can get 240 lah. If you put 240 in, you will also get 1 over 4 IO. Okay, 240 is somewhere here, right? Because here, if you rotate from here to it, where is somewhere here. If here to here is 180 degree. Wait. Oh, from here to here is 180. Then goes to here is somewhere 240. So at here, roughly, is already rotate to here. So the 240, is it 240 minus your 90 degree, because initially it's at 90 degree. How much I need to extra rotate it? So 240, I minus initially 90 degree. I know that I need to extra rotate 210. 210? 210? Hey, why 210? Oh, 210, sorry, dear. Sorry, dear. 150 degree. Thank you, Kai Qian. 150, 3210, and one more is 330. All these answers are acceptable, can be accepted. Okay, this answer, all are correct answer. 10 seconds, digest, and then you tell me any question you want to ask, digest. Okay, the most important, you have to understand the angle that we calculate actually is from way to way. Now, they want you to know the extra angle of rotation from 90 degree. Is it 30 degree, 150? Yes, correct. 30, 150, 210, or 330, all are correct answer. Actually, you get either one answer, you already score the full mark already. Any of you want to ask me any question regarding this question? You must be very clear on the data that we count. Actually, the angle is compared to the first initial filter. Okay, so we get 60 degree is from the initial filter, which is vertically going to 60 degree. But this is not our answer, is because our filter is starting from 90 degree. So 60 degree we cancel out. Then after that, we get 120 degree. We'll also give you the intensity with 1 over 4. But we already at 90 degree, so we only need to give them extra rotation 30 degree. So 30 degree is our answer. It is reference angle, so there is 4 acceptable. Okay, dear, because this one, you see, okay, you see, actually for the same intensity, we can have many angle. We can have many angle. Okay, so any angle that you propose are correct answer. Is it okay, Manjo? Okay, you can propose any answer as long as they are same as what we want. Okay, if let's say intensity is here, this one is IO, 1 over 4 IO. So here, this angle, what is this angle? What is this angle? What is this angle? What is this angle? Okay, because this one 60 degree we don't accept is because we are starting our filter at here. So we find we extra need what? We need extra 30 degree. So it become 120 degree. Why? 60 to 90 is 30 degree what? Right? So at here, another 30 degree. See? Get it? Is it okay? From this graph is much more easier, right? Can you see a clear picture there? IO maximum, I want to find what angle I can get 1 over 4 IO. Okay? Then after that, I calculate I using calculator and I found that 60 degree. But the problem is 60 degree is not our answer, is because our filter B is starting from 90 degree. So the next one that can have also 1 over 4 is actually 120 degree. Okay, so can you see that 90 to 60 to 90 is 30 degree. We're trying to rotate 30 degree. So from 90 to another 30 degrees, 120. Okay? If okay, then this one is what? Then after that, you can get here is 210 degree. And this one continues 330. That's why we got few answer. Okay, as long as the any angle that you propose, it can be give you 1 over 4 IO. That's all. That is our answer. Either one. Not 60 lah. The difference times 2 only 60 times 2. The difference times 2 only 60 times 2. You cannot say 60 times 2. Oh. Because you see 120, the next one is 210 degree. You can find from 60 to 90 is actually 30 degree, extra 30 degree. Then continue to another 30 degree, you will get back the same intensity. So basically, just now this question, just now this question is similar with this, asking you the next intensity, same intensity, how much the angle you need to continue rotate. Okay, it's all quite similar lah. So just now, the last one, the question is, from here, 1 over 4 IO. So what is this? And then what is this angle? Okay, because 90 degree, we are starting from here. So 60 degree, we cannot as our answer. There's a diagram showing us rotate clockwise. So if you propose the answer with 60 degree here, this is a wrong answer because we're already starting from here and then going down. Okay, any other question? If no question, we are going to the lesson 32, 33. Okay, Machine okay or not? Today I didn't see you respond. Machine okay. Okay, then we goes to lesson number 33. Digest. If you really cannot, then you can WhatsApp me and tell me your problems. Okay, here. We goes to chapter 8 regarding the principle of supervision. Okay, supervision is when two waves, they are overlapped. Okay, let's say there is one wave coming, another waves move in opposite direction, and they will meet up at somewhere here. Okay, when they overlap and meet up at a point, the displacement actually is equals to the sum. We add it up together. This is called superposition. Okay, so for the water wave, we got superposition effect. If you are graduate from SPM Malaysia syllabus, actually you know this already. Okay, superposition can occur for both transverse and longitudinal wave, but must be same type lah. You cannot say now I using light and sound wave to superposition, cannot. Light and light superposition, okay. Sound and sound superposition. You got two loudspeaker. The loudspeaker is connected to your computer. Of course, the sound that come out, sound wave that come out is the same type, okay? And then same phase. So these two, we can make a superposition. Okay, must be same type. Cannot like light and sound superposition, cannot. Okay, when two or more waves, they combine to produce a new wave. They can be interference constructively or destructively. Okay, here, if they are same height, same amplitude, okay, this one, a crest and a crest meet up, we will get a bigger crest. Okay, you get a bigger one. So a trough meet another a trough, you will get a bigger trough, 2A, 2 amplitude. Okay, so at the end, overall, can you see that the new wave that you generate is become a bigger one? Add it up together, become a bigger one. This is called constructive. Destructive is what? My crest meet with a trough. An A meet up a negative A. So at the end, you get 0. Okay, then another side also the same. The crest meet with the trough, then 0. Again, 0. If they are out of phase with 180 degree, out of phase 180 degree, that means when I'm crest, you are at trough. If like this, we all the time will get 0. This is called destructive interference. Here, 180 degree out of phase. This one is in phase. We add it up together. This one will cancel out, okay? Then after that here, slideshow. Okay, wait, let me have a look. Okay, this one. When two waves, they meet up together, can you see that it become a higher wave? After that, they move away from each others. When they towards, they meet up. After that, they away from each other. This is called constructive. Okay, this is called constructive. Then destructive is one trough, one crest meet up. Then at the end, at the center here, what's going on? They become 0, and then they split out. They separate out. Okay, this is called destructive. Okay, so this one meet up, become a bigger. A plus 2A becomes 3A. Okay, 1A, 2A becomes 3A. So this one is called constructive interference. Okay, so here, constructive and destructive. Okay. Okay, wait, here. Oh, okay, we do the exercise first. This one okay, easy. Okay, so boys and girls, here we try when this is two signals that approach each other, moving towards each others. Okay, at one instant, the signal completely overlap. According to the principle of superposition, what is the shape of resultant signal? Okay, those graduate from SPM, you try it by yourself. Those new for you, superposition news for you, then you follow me. Okay, we trying to, I draw it out first. Okay, wait. Okay, I draw this out. Follow this, I draw it out first. Okay, then I have to move this wave. Okay, move until assume that it's moving, and then it's overlap. Okay, when it's overlap, it's something like this. Okay, so at here, ask myself, this one is 0 overlap with 0, so I was still getting 0. What? Okay, I still getting 0. So this one, this one, this one, this one. Okay, it's fine. Okay, but then here, can you see that negative A? I meet with another negative A. So I will become negative 2A. Am I right? So this one B is confirmed wrong. Okay, this one negative 2A, okay. This one negative 2A, okay. This is negative A only. So D is wrong. Okay. Oh, Fawal, they already get the answer. Fawal, good. Manjo, yes. Manjo, you know this. Okay. Here, when you goes to the third part had here. 0 and negative A. A 0 meet with another negative A. So you should have negative A what? This part is wrong already. Okay, then here 0 meet with a 2A. Okay, meet with a 2A. So you get a 2A, correct? Okay, so this part is correct. Okay, last one. 0 meet with 0. So 0 lah. Answer is A. Let me have a look. Kai Chen, correct. Good job. Fatima, yes. Machine, yes, good job. So you guys understand about superposition. We goes to number 2. Two progressive waves, they move towards each other in opposite directions. So they meet up, going to meet up. And they form stationary wave. This is your resultant wave, resultant wave. On the graph show you displacement of stationary wave. So dear, this is resultant. This is not one of the wave. This is after two wave, the supervision. Okay, one of the progressive waves is showing you. They're asking you which one should be the other progressive wave. Those who are good, you try first. Okay, don't need to bother me. Those who are new with this topic, you follow me. Okay, so I write it down first. We want to compare few positions. Say K, L. Okay, I got wave, let's say wave 1 and wave 2. These two, we add it up together, we will get a resultant wave, which is my stationary wave. Okay, we look at Z position. Z position at here, my resultant wave. Showing my resultant wave. This is my resultant wave. At position Z, my resultant wave is -5. Am I right? This one is at -5. Resultant wave is at -5. So I write down -5. Okay, we look at another one, K. What is my resultant? The thicker line, my resultant for point K is at 5. At here, this is my resultant at position K. So it's 5. So I write it down. Here is 5. Okay. Then for the L position, my resultant is the thicker line at here. What is my resultant at position L? Which is at 0. So I write at 0. Okay. I determine the stationary wave first. Okay. The resultant wave first. So I determine, I get it. At the point, actually, after we add it up together, we will get a -5, we get a +5, we get a 0. Now wave 1. We look at the wave 1 at here. Wave 1 at position J. The thinner line is my wave 1. Wave 1 is at 0. Am I right? Here is 0. Then K, the thinner line is at 5. Okay. The L, my thinner line is at 10. Okay, so at here, we done already. We can try to find your wave 2. Okay, let me have a look. Fawao? Fawao, no. Okay, any others? I want you to think. This plus this equals to this. What plus this equals to this? And what plus this equals to this? Machine correct. Wesley correct. Powell correct. Manjo leh? Kai Chen correct. Jore correct. Good job. Here the difficult thing is they expect you to read the question. If you are very careless and then you straightly assume this is the two progressive wave that meet up, at the end you thought that they want you to find resultant wave. You found that you cannot solve this question. Here we can solve the question is because the question said that this is a resultant. They don't tell me, they don't tell us what is our another wave. So wave 1, they tell us you have to follow the thinner line at that position. What is the amplitude? 0. Then what is the amplitude when K? Okay. At K, you here. So it's 5. What is the amplitude for L? This is the point, 10. So at the end, your answer should be, just now a lot of you already done, -5, 0, -10. Your answer should be A. Manjo, no. Manjo, check what is the problem. Answer should be A. The unknown wave should be -5, 0, and -10. This is our answer. Okay, boys and girls, any question? Oh, A. Where I write B? It's A. So, Manjo, can you identify the problems? Can you identify why you... Yes, okay. Like boys and girls, we go to the next page. Stationary wave. Last chapter that we learned is called progressive wave. Progressive wave, the wave pattern, they will move. Standing wave, the wave pattern, they will fix at their position. Okay, so this is called standing wave. Standing wave, the energy cannot transfer away lah. Okay, Standing wave, how they get it is because supervision of two waves, same frequency, same amplitude, traveling in opposite direction. Okay, so supervision of traveling wave and reflected wave, okay, they meet up each other. So at here, set the condition. Okay, in your past year, they like to asking you lah how you form the stationary wave. So you have to explain all the two wave traveling in the same speed, opposite direction. Or you can more clearly lah, traveling wave and reflected wave traveling at same speed in opposite direction overlap. Same type, same frequency, same amplitude. Okay, so at here, how it works for the standing wave. Okay, maybe I show you this first. Okay, this one. Okay, let me play how to play. Okay, play. So this is the incident wave come. When they reach to the wall, they will having the reflected wave. The reflected wave will be, we need to use the knowledge that we learned just now lah. Okay, it will reflect it. Cannot move forward, backward. Okay, if like this, they will form. Okay, let me play first. Okay, can you see that? The black color actually is the resultant wave. Okay, after their supervision. Red color is the incidence. Blue color is they reflected back. So when they reflected back, if they meet up at the crest and crest, then they will become a bigger crest. Trough and trough will get a bigger trough. But when they meet up trough and crest, they will become zero. So right now I don't display the incidence and reflected. So this is called standing wave. Can you see that the wave pattern now? They didn't move forward or backward, but they at their own position up and down, up and down. They are standing at here at their own position. So this standing wave, how it produce? It's producing by two wave, incidence wave and reflected wave. When they are same speed in the opposite direction, same type must be same type. You cannot say one is light, one is sound, cannot. Okay, so they were producing this effect. This resultant wave effect is called standing wave, or we say stationary wave. Okay, so if we come back to my slide at here, black color is your resultant. Red color and blue color, one is reflected, one is the incidence. Okay, so can you see that this is the resultant, which is the standing wave. At the end, we're producing such effect. Okay, so at here, the green color 1, 2, 3, 4, 5, 6, 7. The one green color pointing at here at minimum amplitude, that part, this is called note. This is called note. Then the 1, 2, 3, 4, 5, 6, red color. Okay, the red color 1, 2, 3, 4, 5, 6. That is an anti-note. Anti-note is a constructive interference that create a largest amplitude. But for notes, it always zero. It always zero. It's a destructive interference. Okay, so like this, going down, up, down, up, down. Okay, let me have a look. Any others? Okay. We can producing your standing wave by using string. Okay, by using string. So you can adjusting either you adjust the frequency or you adjust the force of the string. Okay, pulling, stretching the string, or how. Okay, you can adjusting and producing different harmonic of the standing wave lah. This one later on. Okay, here we come back to our lesson here. Okay, so you look at here. Blue color is the reflected. Red color is the incident. So this one wave coming and then comes to the fixed point. We were producing the blue color and reflected backwards. Okay, reflected backwards. These two graph, we add it up together using just now the technique that we learned, superposition. So at here, you will find out that amplitude plus amplitude, you get a bigger amplitude. Okay, trough plus trough, we get a bigger trough. So this green color actually is the standing wave. is our final pattern of our wave. Okay, so after t 1 over 4 t period, okay, 1 over 4 period, actually this one the blue color, they will move forward. You see here, this is t, 0 until t. This one is t over 2. Here is t over 4, which means that it moves forward 1 over 4 part of the wave. So at the end, your pattern, you will get like this. Okay, it moves forward. This one move forward 1 over 4. Okay, from here, move forward 1 over 4, so you get this pattern. So this one also the same. You move forward, so you get the pattern at here. So when we add it up together, we found 0. Then here, add it up together, get 0. No matter how, at any point you add it up together, you found that you get a horizontal line. Okay, so from just now, after you pass through 0.25 period, you will going down, here going up, it becomes 0. This one, later on, when we're answering the passive question, we will apply this knowledge. Okay, this one, they continue move forward with another 1 over 4 period from here. So if compared to the initially, it's already half of the period. So this one, half of the period now, here we move forward. So at the end, the pattern that you get this. Okay, we move half of the period. So we get this pattern. So at the end, this plus this, we get this. So between these four, they keep on repeating. So we get our stationary wave. Up, down, up, down. Of course, up to down, in between, we got one part, is they are exactly at 0. So this one, later on, when we do passive question, at least 2 questions, we need to refer back to this question, to refer back to this diagram. Okay, roughly the idea is here. Then we have a look what we need to know about stationary wave. Just like I mentioned nodes and anti-nodes, you have to know where is your node. Node is when their amplitude is 0. So this is node. Okay, antinode is maximum. Okay, we can label here is antinode, antinode. This is node. Okay, so we understand one complete wave from where to where. This one like this. This is called one complete wave. Am I right? But then you see from nodes to nodes, nodes to nodes, this one is actually half of the wavelength. Because one of the wavelength should be from here to here. Okay, so you need to understand 2 adjacent nodes is actually half wavelength. 2 adjacent antinode also half wavelength. Antinode to antinode also. Only a node, oh no. From a node, then goes to another node, one more node. This one is only considered one complete wave. Okay, a node to an adjacent antinode, this one like this, is actually 1 over 4 wavelength. From here to here actually is wavelength over 4. Because from here to here is wavelength over 2. Get the idea? Is it okay, this one? From where to where is one complete wave. Then distance between node and node is half wavelength. Distance between antinode to antinode is half wavelength also. A node to adjacent antinode is half, not half, 0.25 wavelength. This idea is it okay, dear? Okay. Then we learn about phase difference. Okay, previously when we study about the progressive wave, we also got learn about the phase difference. The phase difference on the moment we say that how much they different between the 2 points divided by the wavelength times 360 degree. This is what previously we learned. Okay, what is the different distance between these 2 points divided by the total the wavelength size times 360 degree. This is the phase difference in the progressive wave. But in standing wave, it's totally different. The answer is either 0 or 180 degree. Either one. Okay, so at here, all the particles between 2 adjacent nodes moving in the same direction, and therefore they are in phase to each other. in phase, that means that they are 0 degree. Phase difference is 0 degree. For example, between knot and knot, A, B, C, A, B, C, they all are moving downwards. So they are A, B, C. What is the phase difference between A, B, C? Answer is 0. Okay, particle on either side of knot move in the opposite direction. Okay, if here A, B, C, and D, E, F. Okay, you will find that the D, E, F is green color here. They're moving, trying to moving upward. This one moving downward, this one moving upward. Their phase difference actually is 180-degree phase difference. So when you answer the question, they're asking you what is the phase difference. First question, you ask yourself, this is a progressive wave or standing wave? If standing wave, your answer is either 10 or 180-degree. No others answer. Okay, then you check they are in the same loop or not. If they are same loop, they will be the same direction. So phase difference is 0. So if you ask what is the phase difference between A and E, answer is 180-degree. Okay, is it okay? For the phase difference part, is it okay for you? Or you got any question you want to ask me about the phase difference? Okay, Manjo, okay. How about others? Okay. Only Manjo, Vashini. Okay, Flower, okay. Okay, so we can calculate the V equals to F lambda to find the speed lah. Okay, we try with the, okay, this is summary. Because this topic we learn about stationary wave. Last chapter we learn about progressive wave. Here, standing wave do not transfer energy. Okay, do not. Their wave profile doesn't move away. But progressive wave, they transfer energy. Okay, their frequency all are the same except the notes. Okay, except at the notes. So this one all particle at the same vibrate at same frequency. Okay, because not they not vibrate they not vibrate, they are at 0. Okay, the amplitude will be changes because here they going down will become 0. But for the progressive wave, all the time they just move forward only, but all the time they were having the same amplitude okay, all the point between all the point between successive knot is the same phase. Just now the one this one all the point is the same, so they are 0 degree okay. So this one is progressive. All the point over one wavelength, they will have different phase. They can be from 0 to 360-degree one. How you do calculation? This one previously we learned. What is the distance between the 2 points? Divided by wavelength times either 360-degree or you want to times with 2 pi. Doesn't matter. So this one is previously we learned. Today what we learned for the stationary wave, it only have 2, either 0 or 180-degree. Okay, we try with this question. This one is 2024. Stationary wave. Okay, first we already identified what is the question. Okay, stationary wave. So on the figure 6.2, draw a cross to show the position of knot. Knot is the minimum amplitude. So which means that we can draw at any part. Okay, we can draw at any part to showing your knots. You can draw it here or A or B, doesn't matter. Okay, state the phase difference between P and Q. Like boys and girls, tell me what is P and Q phase difference? Wesley, correct. Vashini, correct. Good job. Fatima, correct. Answer is 0. Because they are in the same loop. Okay, as long as they are in the same between the knot and knot, so they are moving in the same direction, so it's 0 degree. Okay, can you tell me what is the phase difference between P and R? Haichen, good job. Vashini, good job. Fawal, good job. 180-degree. Because this one is opposite direction already. So you refer back to this. Can you see that? This one moving downward, here moving upward. They are 180-degree. Okay? So, but between the knot and knot, in between, they are in the same direction. So the green color here, this one, all green color, they are 0 phase. But if the green color compare with the brown color, this one is 180 degree. Fatima, correct. Manjo, correct. Okay, like dear, we go to your next page here. Okay, you try, before I tell you the answer, try and then you type your answer in the chat box. Oh, Jory, good job. Manjo, correct. Yeah. Machine, correct. I just know. This is stationary wave, Kaichen. This is stationary wave. So their energy will not be transferred. No net energy is transferred. Okay, so boys and girls, answer should be boy. This is stationary wave. Okay, R is anti-knot. R should be anti-knot. Not is anti-knot. Okay, distance between P to T is 3 wavelength. Is it 3 wavelength? Like this is called 1. Then it get extra half. So it should be 1.5 wavelength. I repeat, from here to here is 1 wavelength. So we get another half. So it's 1.5 wavelength. Okay, the last one is, oh, I thought a knot stand for anti-knot. No. Knot is the point with the 0 amplitude. Okay, Fatima, correct. Okay, dear, this one no transfer energy. There are no transfer energy. No energy is transfer. Okay, because they are stationary wave. Their wave profile doesn't move. Okay, so at here, can you see that? Kaixian here, stationary wave do not transfer energy. Do not transfer energy. Their wave profile doesn't move. They just at their own position, up, down, up, down. Okay, here, next. My boys and girls, try. Jore, good job. Fatima, correct. Wesley, correct. Wesley, be confident, yes. Kaichen, correct. Vashini, correct. Okay, no problems, right? Answer is A. Okay, X and Y. Can you see that? They are between knot and knot. So at here, they were moving in the same direction. So their phase difference is 0. That's all. Okay, so here, can you guys try number 3? Stationary wave again. Anjo, no. Are they in phase? Wesley, no. Vashini, yes. Jore, yes. Fatima, no. Fawal, yes. Wesley, no. Maybe I try to draw it up for you. This is not. This is not. Here is not. So at here, it should be something like this, not. Then here, something like this, not. Right there. Okay. So they're asking you S and T, are they in phase? First question, are they in phase? Jahan, correct. After I draw this, S and T, are they in phase? From here, you already can cancel two answer. Can you see that? Are they in the same loop? S is here. Then T is here. They are not in the same loop. Fatima, correct. So at here, first, they are not in phase. These two answer can be cancelled. They are different phase, different 180 degree. So are they same amplitude at the moment? Are they same amplitude? Can you see that? They are same distance from here. They are same distance from here. So are they having the same amplitude? What do you think? Same amplitude or not? Answer C. Yes, they are the same. If you are exactly, okay, if you are exactly at half of it, they will be the maximum. Then if you are exactly from 0, then you left a little bit and right a little bit. Actually, they will get the same. At this position, as long as they from their node, their amplitude will be the same to each others. Is it okay, dear? Can we proceed to the question? Next question, next page. Is it okay, dear? Or any of you got any question want to ask? Okay, we goes to next page. Page number 7. Okay, this one is just now the video that I show you lah. They can adjusting. You can adjust either adjust the frequency or adjusting the tension on the string. Okay, so for this one is they adding up the mass to increase the tension. Okay, so they will change. They will tune the frequency. Okay, tune the frequency to get a different mode of vibration. So we will get harmonic. So we'll get first harmonic, second harmonic, third harmonic lah. Harmonic are the number. Okay, if first harmonic meanings that the mode of vibration, okay, how they vibrate, the mode of vibration, they will give you the longest wavelength. Longest wavelength, we call it as first harmonic. So they will adjust until they get like this. Then this one reflected. So they only up down like this. So this is the longest wavelength because one complete wavelength like this. Okay, so they are fixed at both ends. So this part is actually a long wavelength. It will cost you a long wavelength, something like this. Only consider one complete wave. Okay, so they are, we can either adjust the frequency or adjust the tension of the string so that we can get different mode. Okay, so later on you will see that different mode. Okay, so this one is called first harmonic because the wavelength is very long, something like this. Cannot draw back. Okay, like this. It's one complete wave. But this is one complete wave. Here is one complete wave. Okay, so the longest complete wave, we call this as first harmonic, second harmonic, and third harmonic. So they can adjust. Okay, so this is a few example. They might be asking in your AS past year question. So they will adjust, they will transmit the microwave. Okay, it will reflect. When they reflect, they will superposition. When they superposition adjust until a certain frequency, they're able to get this stationary wave. Okay, they adjust the frequency until the incident wave and the reflected wave, they are in opposite direction. They're having the same amplitude. Then at this moment, we can producing the standing wave pattern. Okay, so they're using the microwave detector moving the along the line. Okay, they're moving. So if they are if they are at the maximum, they're able to detect the maximum. That means this point is actually anti-node. If they detect the minimum, this is node. So anti-node, 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 anti-node. They will tell you that, hey, I move along the line, I get 4 anti-node. Something like this. So we roughly from their information for anti-node, then we can predict the pattern. We can know the pattern that we get along the path is actually like this. Okay, so they might be didn't draw for you, but they tell you that I move microwave detector along the path. I get 4 anti-nodes. 1, 2, 3, 4. Then we can draw this diagram out. Okay, so not only using microwave can show you the standing wave, but also the string also can show. So just now the the PowerPoint that I show you is string. So they can adjust. Okay. Then sound wave. sound wave, it also can show you the standing wave, or we say stationary wave. So we have the dry powder along here. Okay, then we play with the speaker. Then because it will vibrate, what particle will vibrate. So at the end, we found out they will have some certain region, the powder will accumulate at this position. If they are, if they can be accumulate at here, that means that this point actually is node. If anti-node, they will vibrate and move the powder away. Okay, so those part without powder, this is anti-node. Okay, let me show you. Okay, this one. You see the powder. So those without powder one actually is the anti-node. It vibrate and make the powder away. Those with a lot of powder, that means that this one, the particle at here is actually, they are nodes at the point of node. Okay, so they can adjust the frequency and then they get a different pattern. You see? Yeah, something like that. Okay.
小红书
Okay, there we go to your next page. We try with the past year question, so that apply what we learned using the past year question. Okay, in the experiment to produce the stationary sound wave in the air, okay, the powder is initially evenly distributed, but at the one open end of the tube, a loudspeaker emits the sound wave. Okay, stationary wave is formed and the powder will accumulate in this pattern. Okay, what statement explain the position of the powder within the tube? Okay, can you try? Can you try? The pulse are what condition we have this pulse? Well, is it maximum amplitude? If maximum amplitude, that means that you are in the anti-node. Minimum amplitude, that means that it is at node. Fatima, correct. Manjo, correct. How about others? Jahan, correct. Okay, here, this one, here should be at anti-node, this, node. Then, without the powder, it should be the maximum. That means that your wave at here is something like this, going. So difficult word. Okay, this one is your note. Notes, 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 notes. Okay, then go here, and then I go down, go up, and then I go down, go up, and then I go down. Oh my god. Here I go. Okay. Then I complete the reflected wave. Going here, going here. Okay. Yeah, this is the wave pattern that I can show to you. So can you see that? Kai-Chen, correct. Your answer should be B. Okay? With the powder, that is the node. With the powder, that is the node. Without powder, that means that the vibration make the molecule vibrate, make all the particle away from it. Okay, so this is the answer B. Is it okay? Can I proceed to the next question, dear? Okay, we try with the next question. The speed of the sound is V. They ask you to find frequency. V equals to F lambda. That means that we need to, from the diagram, to find out your wavelength. To find out your wavelength. Okay, so like what I told you, so this one make note, here make note, here make note, here make note. Okay? Then note to note. So this one I can draw something like this, go down. Here, go down, go up. Here, go up, go down. Okay. Then I draw the reflected one using red color. Okay, so boys and girls, between the 30 cm, this is the wave. So can you guys tell me 30 cm equals to how many wavelength? Correct, correct. Good job. How many wavelength, dear? Is it one wavelength? Wow, good job. It's 1.5. Yes, correct. Okay, this to here is called one wavelength. Then here is another half. So 30 cm is actually 1.5 wavelength. So your wavelength actually is 20 cm. Of course, when we do substitution, we need to change it into 0.2. This one change to 0.2. Okay, your speed is 330 cm. That's why I need to change. Okay, so your frequency should be A. Your frequency should be 1650 Hertz. Is it okay, dear? Jahan, check which part is different with mine and which part actually is wrong. Is it okay, dear? If okay, then we are going to proceed to the next question. Jahan, okay or not, Jahan? Okay, dear. We will have three cases. We have to study about the stationary wave. One is called both end is fixed. One is called one end open, one end fixed. Another one is both end open. Okay, we got three cases. We got three cases. Let me show you the three cases here. Okay, we will have three cases. Okay, first one is both end are closed. Another one is one end closed, one end open. Another third case is both ends are open. We look at here, we will find out that if they are closed or we say fixed, it must be a node. Must be. If open, it must be anti-node. Open, it must be anti-node. This is called node. Okay? So right now, it comes to the first case. First case is both fixed ends. Both ends are closed or we say fix it, okay? So at here, they must, not, okay? So we adjust. Stationary wave can have different wave pattern that we call as harmonic. That's why I just now told you first harmonic, second harmonic, third harmonic, okay? As you increasing the frequency, you are increasing the harmonic. So you look at the first case at here. This one is how many wavelength? What do you think? Is it one wavelength? This is length equals to how many wavelength? Yes, Kai Chen, correct. Half of the wavelength, am I right? Okay, so you look at here, dear. This is half. If you want one complete, actually it's like this. So right now, it's actually half of the wavelength, half. The length from here to here, the length is half wavelength. So your wavelength equals to 2L. Do you agree? Your wavelength actually is 2L. L equals to wavelength over 2. So wavelength equals to 2L. Okay? Then this frequency, we want to know about the frequency. Okay? Frequency is just now, what we learned, V equals to F lambda. Frequency is V over lambda. Okay? So at here, V over your lambda is 2L. Your wavelength is 2L. So this one, we call it as first harmonic. It's because this pattern is giving you the longest wavelength. So just now in the theory here, we got mentioned, where is it? Let me have a look. Here. First harmonic is the mode of vibration with longest wavelength. We call it as first harmonic. So we come back to here. This one, wavelength is the longest compared to others. Can you see that compared to others? So this one, we call as first harmonic. Okay, so V over 2L. Then we look at second case. We're starting to increase the wavelength, increase the frequency. So when we increase the frequency, of course, the wavelength will become shorter lah. Because frequency is number of wave in 1 second. You produce more wave in 1 second, what? So your wavelength confirm become shorter. Because end to end, the end fixed end to fixed end, there must be a note. So the next pattern that we will get will be like this. Then this one, the length is exactly equals to a wavelength, right? It will exactly equals to a wavelength. So wavelength 2 is exactly equals to the length that we measure. If we do substitution at here, okay, V over L, then I want to compare with the first one. How many FO? Okay, how many fundamental frequency? Then at the end, I found out that when we go to the second harmonic, actually it's double of your FO. Exactly double up, 2 FO. Then we go to third harmonic. End to end must be a note. The next pattern that we can get after we continue increasing your frequency, we found out that we will get this pattern. So this pattern, the length that we measure, actually we can one complete wavelength plus half of it. So 1.5 wavelength lah. 1.5 wavelength for the length that we measure actually is 1.5. So wavelength become 2 over 3 length. Okay, it's just mathematic move lah. Okay, dear. Then after that, when we apply this wavelength into the formula at here, at the end we found out that it will become 3FO. So from these three pattern, we can make a conclusion. We can make a conclusion. You want to find the number of the harmonic, the frequency for the certain harmonic, actually Fn equals to Nf times O. If you want to find the fourth frequency, then you just using 4 times Fo settle. Then you already get the answer. Okay, so we can just using it as long as we know our Fo, then third, second, or fourth, fifth, doesn't matter. Just times it only. Okay, the lowest frequency means that the longest wavelength. Lowest frequency actually is longest wavelength. In the system, we call it as first harmonic. The frequency we can call it as fundamental frequency. Okay, different mode of vibration we call it as harmonic. Okay, harmonic is the mode of vibration multiple of the first harmonic and of first harmonic. Okay, this is new thing for you guys. We can try to use the exercise to helping us to understand more about the theory part. Okay, so right now I just need you to have an idea. From here to here, the most important thing I want you to know is from here to here is actually half wavelength. Okay, then from here to here is wavelength. From here to N is 1.5 wavelength. Okay, then frequency that we want to find, we can using number of harmonics times with your fundamental frequency. That's all. We try pass your question here. Two progressive wave of frequency 300 Hz, they superpose and producing a stationary wave in which the adjacent note. So this one is note to note lah. So note to note at here is 1.5. Length is 1.5 meter. What is the speed V? Okay, what is the speed V? So boys and girls, you know the frequency. V equals to F lambda. You know this 300 hertz, but you don't know the wavelength. Can you help me to find what is your wavelength? Then you substitute in and tell me your answer. Correct, Wesley. Good job. How about others? Machine correct. Yeah. Jore, yes. Okay. So boys and girls, this one, if I continue drawing, this one only consider one complete wave. Right? This is one complete wave. So the 1.5 meter, yes. This is only half wavelength. Right? Taichen correct. Manjo correct. So your wavelength should be equals to 3.0 meter. 3.0 meter. So you should 900 ms negative 1. So boys and girls, is it okay? Can we proceed to the next? Give me a reaction so I know that we can proceed or not. Okay. Like a corridor is 13.2 long, has closed door that reflects sound at both. So both are closed. That means this point must be a node. Okay, the speed of the sound is 3, so this is V. What is the lowest frequency? They want you to find the frequency to create a stationary wave in the corridor with a not half wave with it. So this is also not. So that means that is something like this. Okay, here. Okay, can you try and then tell me? What is your final answer? Machine, good job. Well, correct. I can correct. Okay, frequency we don't know. Speed 330. Wavelength. What is your wavelength? So you can from the diagram to know your wavelength. This is a one complete wave, dear. One complete wave. That means that this length is equals to your wavelength. So 13.2 frequency should be 25 hertz. Answer should be C. Right, dear? Okay, we goes to question number 3. Is it okay? Can I go? Question number 3, a little bit challenging, a little bit, but we can try. Okay. Vibration generator, it move up, down lah, okay? When the vibration generator is vibrating at a frequency F, a stationary wave with 5 notes. Where is the 5 notes? 1, 2, 3, 4, 5. It's created on the stretch string. There is a note at the end of the note that, okay, frequency of the vibration is slowly increased. When at frequency F, okay, this is at frequency X, they vibrate at frequency F. Okay, can you tell me, this is what harmonic? What number of harmonic? This is called first harmonic. This is called second harmonic. So this is how many harmonic right now? Kai Qian correct. Wesley correct. So this one actually is fourth harmonic, right? Fourth harmonic. That means that here F4 is actually F, right? Okay, we understand just now we said that this is general formula. Then this what diagram show you is 4 harmonic. So this one should be 4 FO equals to F because they tell you that this is at frequency F. Okay? So what is your FO? Is 1 or F over 4. Do you agree until here? So my question is, what is your FY? Next frequency that you can produce. Correct, Fawal. What is your F5? Fifth harmonic. Right, boys and girls, any of you? Fawal, good job. Mashini, yeah, correct. IFO. Relate it to the F. 5F over 4. So your answer should be 1.25F. Is it okay? So boys and girls, is it okay? Okay. How about others? Previous question. 2C. Wesley, 2C. Okay. Wesley, okay or not? 2C. Manjo cannot. Manjo, which question cannot, dear? Manjo cannot. Manjo, this one is general formula. We know that end to end, close, fixed end. There must be not and not. Okay, so at the end, we use the theory part. We found out that there is a sequence. So at here, this one is called, if like this, is called first harmonic. Like this, called second. First, then second, third, and then fourth. So this is actually fourth harmonic. Fourth harmonic, they tell you that frequency is at F. Okay, fourth harmonic is equals to 4FO equals to the frequency they give us. So I can count what is your FO. Then the next frequency is the fifth one. So I just do some substitution. Can but wrong. Okay. Okay, dear. Here. Two waves of equal frequency and amplitude traveling in opposite direction. You know, guys, stationary wave must have same amplitude. If you are not same amplitude, you won't be able to cancel out, you know. You won't be able to cancel out and then move up, down, up, down, up, down. Okay? So at here, they will form stationary with 3 note and 2 anti-note. Okay. 3 note, 1, 2, 3. And 2 anti-note. So that means that your pattern will be like this. Like this, right? Okay, reflected. This is the reflected. Something like this, okay? Then they tell you that frequency is double up. If your frequency is double up, frequency is number of waves in 1 second. If you double up, now I got one complete wave. I double up my frequency, that means that I will have 2 complete waves. Am I right? So at here, I will get this is called 1 complete, right? I need to get extra. So I will roughly get like this. This is 1 complete wave. I will get 1 complete wave. Oh, so ugly, my drawing. Like this. Like this. 1. I will get second one. You get what I mean or not? Frequency is number of wave in 1 second. Now how many wave? I got 1 complete wave. When I double up my frequency, I will get 2 waves in 1 second. 1 complete wave become 2 complete wave. So at here, I repeat, drawing the stationary wave. Something like this, like this, like this. Okay, they ask you, how many anti-nodes are there in your new stationary wave? Yes, correct, Manjo. Okay, let me check. Mashini correct. Fatima correct. How many anti-nodes? Anti-note. We got 4. Is it okay? Answer is donkey. Can we proceed to the next page, dear? Can we proceed to the next page? Yes. Okay, let's go. Okay. Can you draw a cross at one position that there is a knot and another cross for there is an anti-knot? Label the knot as N. Okay, knot. Knot is minimum amplitude. So here I label here, this is knot. Anti-knot is at maximum, so I label here. You can draw at any point, as long as it's maximum amplitude and minimum amplitude. Okay, so that means that I can label here, here as my knot. Doesn't matter. Here, here, here as my anti-knot. Show that the wavelength is 0.32. Do it right now. Don't refer to mine. At the same time, I write the working step. Prove to me your wavelength is 0.32. The length is 0.48 meter equals to how many wavelength? You able to get the answer? Same as me. Easy what, right? Can? Can you calculate the frequency? V equals to F lambda. We got the speed already. Can, Vashini? Can. 2 to 3 significant figure, We already show the answer, explaining the reasoning. We show that the length is 0.48 actually is for 3 over 2 wavelength. It's for 3 over 2 wavelength. Actually, our working step is already explaining how we get the 0.32. So that is fine. Okay. So boys and girls, did you able to get the answer for frequency 4400 or 4380? Can we proceed to the next question, dear? Yes, let's go. Let's go. Okay, two progressive waves meet to form amplitude. Need to form stationary wave. They must have same amplitude. Okay, same amplitude. Either one, okay. Then after that, same wavelength, same frequency, same speed. There is one more condition that very important for them to produce stationary wave. Any of you got any idea? One more condition. No? Constant phase difference is there can be 180-degree phase difference. What? Machine, yes, good job. Wesley, yes, they must be travel. They must be travel in opposite direction. We come back to our notes, Let us have a look. Yeah, see? Travel in the opposite direction. Same speed, same type, same frequency. No opposite direction. If they are in the same direction, you never superposition one. Okay, is it okay? The difficult part is coming. The difficult part is coming. Okay, here stationary wave is formed on the string that is stretched between two fixed point A and B. Figure 5.1 show the string at the time t equals to 0. When each point is at their maximum displacement, distance AB is 0.18. Okay, whole part is 0.18. Period 0.016 second. On the figure 5.1, sketch a solid line to show the position of the string when at the time 0.004. This is one complete wave. Okay, they swing, it's up, up, down, down, come back to the original position. Actually, it's considered one complete wave. This part position go up, go up, go down, come back to original position is considered one complete wave. This time, they need the period of the stationary wave is 0.016 second. Okay, 0.004 second is how many period? How many period? Not even one period, what? Right? So what is the fraction of the period? Is it 1/2 for a while? One complete period, one complete wave, it need the period is 0.016 second. Now it's 0.004. So, yes, correct, for a while. 0.004 divided by 0.016. One period is 0.016 second. Now, I want to know 0.004 second is how many t? So at the end, you'll find that it's actually t over 4. Do you agree, dear? 4t. Okay, we cross multiply it. Using a mathematical cross multiply it. Okay, yes, correct. Okay, here. Just now I told you what? This one moving up, and then coming down, is one complete t. So it needs 0.004, 0.004, 0.004, 0.004. So right now the question asking you 0.004 second. Where is the point at here? What do you guys think? Where should I go for this point? Where should I go, dear? Yes, correct, dear. Manjo, correct. So, dear, here, move up is 0.04. 1/4t. What? So that means that this one, it will come to here. This one going down, going down, going up, going up. So that means this one also going down. So at the end, t equals to 0.04 second. Actually, how they get, how their pattern is exactly a straight line. We label this as line P. Now, I come back to the notes that I say important, and we will have 2 questions involved with this. Now, I come back. Where is the part? Where is it? Oh, here. Let me see whether I can capture or not. Is it copy? Wait, what is this? See whether I able to copy. No, I cannot copy. Why? If cannot copy, then I just show at here lah, dear. It should be able to copy what? Oh, cannot, Let me have a look. Is it can be like this? Is it copy? Yes, copy. Paste. Oh, cannot. It's just copying. Okay. Then, boys and girls, I just explain on the diagram here lah. Okay. Okay, can you see that at here? After 1/4t, if you got at maximum, at the end they will get a straight line. If you are at here, also another maximum amplitude. Next 1/4t, you also get a horizontal line. So based on this diagram, to understand what is your wave pattern after 1/4, is it okay for you using this diagram for you to have a look? You need to go 1 time, 2 time, 3 time, 4 time. So 1 over 4 is in moving down, then the bottom part going up, so they form a horizontal. Is it okay using this diagram to help you understand? Is it okay? Yes, Then I stay in this diagram. I want you to try if time is equal to 0.024 seconds, it's actually how many t? The period. 0.024 seconds is actually how many period? Then after that, you come back to this diagram, my screen here. Then you try to think, what is the pattern at 0.024 seconds? What should be the pattern? How many complete t, right dear? Any of you? 0.024 second. 1t is 0.016 second. So it's actually how many t? Fawal correct. But she didn't know. One complete wave is 0.016 second. What? Now it's 0.024. It's more than one. More than one complete t. Jore correct. Fatima correct. Then right now I need you to think. So how was the pattern? Manjo correct. Okay, the correct t is 1.5 t. One is meaning that it repeating already. One complete t is that means that the pattern will go back to the original position. So it's already repeating. So the important thing is we need to think 0.5 t. So how was your pattern if after 0.5 t? So what do you guys think? Will it get the exactly same wave, which is zero phase different? Yes, Manjo correct. So Manjo, right now you get the idea. Right now you get correct. It's because you already understand it, is it? Yes, good job. So boys and girls, I repeat, if you are going to the complete T, you get back the same pattern, same wave pattern. Okay, if you get back the T, actually you get back the same pattern already. So the 1.5 T, one we no need to think because it's get back the original shape. The important thing is we think about the 0.5 T. After 0.5 T, it will terbalik. Can you see that? Terbalik. Okay, upside down. The pattern will upside down. So at here, we come back to our nurse and our past year question at here. So how was your this one? Okay. 0.024 divided by 0.016 actually is 1.5 T lah. The one actually is already repeat the pattern. The most important, we need to think how about the 0.5 T. So 0.5 T, that means half T lah. So for example, at here, go up is 1 over 4. Go up again is 1 over 2. So that means that 1.5 T, if you want to study about 1.5, also never mind. You see, 1, go up, go up, go down, go down. This is 1 complete. 1 complete, then continue, go up 1 over 4, 1 over 2. So at the end, what is the final position? It should be at upper part. So our next pattern, it should be here. Going up, then going down, going up, then going down. This one should be your line Q. Wait, why just now my blue color become, wait, why my blue color become red color also? Okay, like this. This is my P. Is it okay? Can you guys get the idea? So this one is at the bottom part, I go up, go down, and then go up again. So my final actually is at upper part at here. It will terbalik the pattern. Okay, is it okay, like boys and girls? Tell me. Okay, okay, this one we write final answer and you try 25 meter per second. From here to here is actually 0.8 meter. Okay? You write 25, then you complete it by yourself. If you really cannot WhatsApp me, I tell you how to do. I show you the working set. Okay, until here, okay? Can I proceed? Last question. Okay, come here. Okay. How the stationary wave is producing? Wow, okay. So at here, wave travel along the string and reflected at fixed point. Okay, then incident wave and reflected wave superpose. Okay, like this too much. Okay, how stationary wave is formed? This is too much. Okay, next. Sketch a line to show a possible position of the string a quarter. That means 1 over 4 t. Right? So what do you think? How was your pattern for the first part at here? Any of you can tell me. Is it still horizontal or it go down or go up? Any of you? 1 over 4. Then here they say that point P is moving downward first. It moved downward first. Now the question asking you to scratch a line to show how possible the spring position a quarter of a cycle. Any of you can tell me? What is your idea? Where it go after 1 over 4? Fawad, correct. 1 over 4. Is it getting back here? Or going down? Or going up? How was the pattern? Yes, Manjo, correct. 1 over 4. 1 over 4, Wesley, 1 over 4. And initially, the point P is moving downward. So it will go down, go up, and then go down. So 1 over 4 actually, where is it? 1 over 4, where is it, Wesley? 1 complete is go down, go up, and then go down again. Yes, Wesley, correct. Boys and girls, one more time. We come back to the diagram here. That's why I told you this diagram is important. Where is it? Okay, here. Okay, like this. After 1 over 4t, where it go? It go down first. So your pattern for this point P, just now the diagram point P, is going down. So this is the pattern after 1 over 4t. Teacher, why not going up? Yes, it can be from here and then next one is going up. But just now the past year question, there is one sentence tell you that point P is moving downwards first. So at here, our answer, here, you see, the point P is moving downward. So that means that here, we need to go down, go up, and then go down is considered one complete wave. This is 1 over 4t, another 1 over 4t, another 1 over 4t, 1 over 4t. That means that is one complete wave lah. Okay, it's too messy. Let me clean it. So that means that 1 over 4, it actually should be somewhere here. So I draw my pattern. It should be like this, like this, like this, like this, like this. So this is my time after time is equals to 1 over 4t. This is the possible position. This is the possible position of the string a quarter of a cycle. Is it okay, dear? Is it okay? Okay. What is the horizontal distance? Okay, last one. Horizontal from A to B. Oh, okay, from A to B. You got the speed V, you got the period. Period is T, but from T here, you can find frequency. So V equals to frequency wavelength. After you find your wavelength, it's not your final answer. Now it's not asking you wavelength, it's asking you from A to B. So you ask yourself, A to B, how many complete wavelength? Wesley, which part? I need to repeat. B? Is it B? Wesley, is it B? B, ah. Okay, Wesley, you see, ah. One complete wave is actually, this one, this point. One complete wave is actually in moving upward, upward, downward, and then downward. Sorry. Initially is horizontal, okay? Initially is horizontal. So, because the question tells you that it's moving downward first. So at here, it going down, going up, going up, going down is considered one complete wave. So for this one, Wesley, do you agree? This is one complete wave. T, after T. Okay, so you will understand, you see 1, 2, 3, 4. So 1 over 4 actually is from here, going down is 1 over 4. I need to draw another wave to show, because after 1 over 4, this wave, it will become here. So it's like this, we come back to here, dear. It doesn't allow me to copy here. Okay, right, dear? Your, Wesley, your wave is actually keep on moving. But it moving up, down, moving. At a certain moment, actually, it's totally becomes zero. So it's like what our PDF file showing you. You see? So at what time, actually, different time, it will getting different position of your wave. What? So they're asking you after 1 over 4, where is your wave right now? So we're trying to draw the wave pattern after 1 over 4. I saw my laptop and my iPad is a bit lagging. Wesley, after T, it will exactly go back to original position. But before you complete 1T, it will having different position. So they ask us to sketch out what is your position of your wave when the time is 1 over 4t. So Wesley, you can tell me your confusing part so that I can explain to you. Good job. So at here, just now is at here. The wave pattern is at here. After 1 over 4, it become this position. Another 1 over 4, it become horizontal line again. Another 1 over 4, it get like this pattern. That's why the past year question at here, what they're asking you is, initially this is the t equals to 0. Okay, the horizontal line is t equals to 0, the pattern. So this one, initially like this. T equals to 0. So after t equals to t over 4, so how was your pattern? Your pattern will become like this. Something like this. Is it okay, Wesley? We move up, down, up, down, up, down. Okay. So boys and girls, can you tell me what is your final answer? Before we end our lesson, what is your final answer? Any of you? Huh? Is it hard for you guys? See? What is the horizontal distance between A to B? Wow, no, Manjo. How you get it? Jore correct. Machine correct. They give you speed is 35. Frequency is 1 over T. What? So at here, frequency is 1 over 0.04. Then you get the wavelength. From here, my wavelength is 1.4 meter. Am I right? Oh, Wesley? Is it you didn't do conversion? Power correct. Manjo, do you know what is the answer? Okay, ask yourself. From A to B, how many complete wave? Here to here is one wavelength. Here to here is another one complete wavelength. Then here to the end of B is half wavelength. So it's actually distance from AB actually is 2.5 wavelength. 2.5 times 1.4, your answer should be 3.5 meter. You really put the T inside the frequency, cannot. How about others? Do you able to get this idea? Is it okay, everybody? This chapter is new thing for you, so you go back and digest again, okay? So if no others question, that's all for our lesson today.